this lesson I will solve the ministerial questions of the topic of differentiation and tangent line, page number 104 in the book of ministerial's question. Question number 1, find f of x that satisfy f of 0 equal 3 and f prime of x equal negative 5. Since the derivative of the function is constant, then the function is linear function with y-intercept 0, 3 and the slope of negative 5. Then the function is y equal to negative 5x plus 3. Choice A. Question number 2. Find f of x that satisfy f of negative 1 equal 3 and f prime of x equal negative 2. Also, the derivative of the function is constant, then the function is linear with the slope of negative 2 and point negative 1, 3 lies on the line. Therefore, we use the y point slope form to find the function y minus y1 equal to the slope negative 2x minus x1 minus minus 1 plus 1. Therefore, y will be equal to negative 2x, negative 2 plus a 3 will be positive 1. Choice A. Find f of x that satisfy f of negative 1 equal 2 and the derivative of the function is negative 3. Negative 3 is constant, then the function is linear with a slope of negative 3 and point negative 1, 2 lies on the line. Then y minus y1 equal to the slope x minus minus 1 plus 1. Therefore, the function will be y equal to negative 3x minus 3 plus 2 will be negative 3x minus 1. Choice A. Question number 4. Find f of x that satisfy f of negative 1, 3 and f prime of x is 0. Since f prime of x is 0, then the line is horizontal line, negative 1, 3 on the line, then the line is y equal 3. Find the function f of x that satisfy f of 1 equal 2 and f prime equal negative 3. Also, the slope is negative 3 and the point 1, 2 lies on the line. Then y minus 2 equal to negative 3x minus 1. Therefore, y equal to negative 3x plus 3 plus 2 equal to negative 3x plus 5. Negative 3x plus 5, choice number C. Question number 6. Find the function that satisfy f of 2 equal negative 1 and f prime of x equal negative 2. Also, the slope of the line is negative 2 and the point 2, negative 1 lies on the line. Y minus y1 minus minus 1 plus 1 equal to the slope x minus x1. Then y equal to negative 2x plus 4 plus minus 1 equal to negative 2x plus 3. Negative 2x plus 3, choice D. On which of the following graphs is f prime of x less than 0 for all value of x? F prime of x is less than 0 when f of x is decreasing everywhere from negative infinity to positive infinity. This function is decreasing from negative infinity to positive infinity. Therefore, f prime of x is less than 0 for all value of x. But this function is not decreasing, it's fixed uh, function, f of x equal negative 2. This function is increasing from negative infinity to 0, then decreasing from 0 to positive infinity. Also, this function is increasing from negative infinity to this point, decreasing from this point to this point, and increasing from this point to positive infinity. Therefore, the right choice is A. The value of the derivative of which of the following are all negative? Also the same of the previous question. We want the value of derivative to be negative at all value of x, then the function should be decreasing. This function is decreasing from negative infinity to positive infinity. Take this direction, but this function is increasing, then decreasing. This function is increasing from negative infinity to positive infinity, then f prime of x is greater than 0, positive for all value of x. This function changed from increasing to decreasing and increasing. Only this function is decreasing from negative infinity to positive infinity, then its derivative is negative for all value of x. Ministerial question of continuity and differentiability, page number 106. Question number 1. Which is continuous and differentiable at x equal 3? The first function, f of x equal absolute value x minus 3 over x minus 3. This function is not continuous and not differentiable at 3, since 3 is not in the domain of this function. B, f of x equal x power 2 when x less than 3, 6x minus 9 when x greater than or equal 3. Let us check the continuity of this function. This 3 is in the domain. F of 3 equal to 6 times, I substitute in this segment since 3 belongs to this interval, 6 times 3, 18 minus 9, 9. The limit of the function is when x approach to 3 from left, substitute in the first segment 3 power 2, 9, and from the right it is the same, the value of 3 equal 9. Since the value equal to the limit, then this function is continuous. For the differentiability, differentiate both segments, 2x when x less than 3, 6 when x greater than 3. Then find the limit when x approach to 3. From left, it is 2 times 3, 6, and from right also it is 6. Therefore, the function is differentiable at 3, and this is the right choice. For the choice C, 3 is in the domain. F of 3 is 3 squared, 9 plus 3, 12. The limit of the function is from left 3 times 3, 9 plus 3, 12, also 12, then the function is continuous. But for the differentiability, if we differentiate this function, f of x equal to, f prime of x equal to 2x plus 1, for the other segment is 3, when x less than 3, when x greater than equal 3. Greater than 3. If we find the limit from left and from right, from left is 3, but from right 2 times 3, 6 plus 1, 7. It's not equal to 3. Therefore, this function is continuous but not differentiable at 3. The right choice is B. Question number 2. Which is differentiable at x equal 1? This function is not differentiable at 1 since 1 is not in the domain of this function. F of x equal absolute value x minus 1. This function has a vertex at 1. Therefore, this function is not differentiable at vertex of this graph. For choice B, f of x equal 3 over x minus 1 to the power negative 2, the function, if we rewrite it, then the function will be x minus 1 power 2. This function is differentiable at x equal 1, since the derivative of this function is 6x minus 1 to the power 1, and f prime of 1 equal to 0. Therefore, the derivative of this function exists at x equal 1. For the last choice, f of x equal cube root of x minus 1, this function is not differentiable, since if we rewrite this function as x minus 1 to the power 1 half is less than 1, therefore it is not differentiable, because the derivative of this function is 1 over 3 x minus 1, 1 over 3 minus 1, negative 2 over 3, and f prime of x equal to 1 over 3 x minus 1 cube root square. Therefore, f prime of 1 equal to 1 over 3 times 0, 1 minus 1, 0. 1 over 0 is undefined. Therefore, the right choice is C. Which is differentiable at 0? This function has a vertex at 0. Therefore, it is not differentiable. This function also not differentiable at 0, since 0 is not in the domain of this function. F of x equal 3 over 5. This function is not differentiable at 0, since 3 over 5 is less than 1. F of x equal x to the power 3 over 2. It is differentiable since 3 over 2 greater than 1. Because if we differentiate this function, f prime of x equal to 3 over 5 x to the power 3 over 5 minus 1 negative 2 over 5 equal to 3 over 5 x to the power 2 over 5 at the derivative at 0 equal to 3 over 5 times 0. 3 over 0, it is not exist. But for the choice D, f prime of x equal to 3 over 2 x to the 3 over 2 minus 1, 1 over 2. Then f prime of 0 equal to 3 over 2 times 0 equal to 0 exists. Therefore, the right choice is D. If f of x equal negative 1 over x, then find limit x approach to negative 2 for f of x minus f of negative 2 over x minus 2. If we compare this limit with limit x approach to c, f of x minus f of c over x minus c, which is the derivative of the function f at c, then we will see that this limit is the derivative of this function at x equal negative 2. Then we want to find the derivative of this function at negative 2. Rewrite this function as negative x to the negative 1. Find the derivative x negative 1 times negative x to the negative 2 equal to 1 over x power 2. F prime of negative 2 equal to 1 over negative 2 squared equal to 1 over 4. The right choice is C. Question number 5. If f prime of negative 2 equal to limit x approach to negative 2 for 5 minus 2x power 2 plus 3 over x plus 2, find f prime of 1. If we compare this limit with the limit of function, the definition of the limit of function when x approach to c, it is f of x minus f of c over x minus c. Therefore, f of x is 5 minus 2x squared. Then find the derivative of this function equal to negative 4x. Then find the derivative at 1 equal to negative 4. Choice C. Which is differentiable at x equals 0? At x equals 0, let us check the differentiability for this function. F prime of x for the first function is 1, negative 1 when x greater than 1, x less than 0. Therefore, the limit of the derivative of this function from right is 1, from left is negative 1. The limit is not exist, therefore this function is not differentiable at x equal 0. For the second function, let us check the continuity of this function. First, f of 0, substitute in this function equal to negative 4, 0 square minus 4, negative 4. Limit when x approach to 0 from left, substitute in this segment 4 minus x squared equal to 4 minus 0, 4. And the limit when x approach to 0 from right, substitute in this segment x power 2 minus 4, 0 power 2 minus 4 equal to negative 4. Since the limit from left not equal to the limit from right, therefore this function has no limit and therefore it is not continuous. And since it is not continuous, then absolutely it is not differentiable at 0. This function, we solved it before, it is continuous at 0, but it is not differentiable. Since if we want to find the differentiability at 0, then limit when x approach 0, f of x, x minus x sine 1 over x minus f of 0, 0 over x minus 0, x with x. Then the limit when x approach to 0 to sine 1 over x, it is oscillating between 1 and negative 1. Therefore, the limit is not exist. This function is not differentiable. For the last function, it is differentiable because if we set x power 2 sine x over x minus 0, x with x, the function will be x sine 1 over x. Using Squeeze theorem, we will find this limit equal to 0, then the differentiability exists at 0. Therefore, the right choice is D. Question number 7. If f is odd and has differentiability for all and x, and this table is some value of the function f, if limit x approach to c equal f of x minus f of c over x minus c equal 32, and f of a plus 3 times f prime of negative c equal to f of negative 2, find f of a squared minus 4 over a. To find f of a squared minus 4 over a, we need to find the value of a. To find the value of a, we will use this equation. This limit is f prime of c from the definition. Then f prime of c equal to 32. We need f prime of negative c. Since f is odd, then f prime is even. And since f prime is even, then f of negative c also equal to 32. We find the first unknown value, f of negative 2. Since the function is odd and 2 negative 65 belong to function, then negative 2 65 also belong to function. Therefore, f of negative 2 equal to 65. Now, f of a plus 3, f prime of negative c, 32, equal to f of negative 2, 65. Therefore, f of a equal to 3 times 32, 96. Take it to the right side. Negative 96 plus 65 equal to negative 31. Therefore, f of a equal to negative 31. If we look at the table, we will see that f of negative 1 equal to 31. Since negative 1, 31 belong to the function and the function is odd, then 1 negative 31 is also belong to the graph of this function. Therefore, the value corresponding to negative 31 is 1. Therefore, a equal to 1. Now, f of a squared minus 4 over a equal to f of 1 square 1 minus 4 over 1, 4, equal to f of negative 3. Since 3 negative 81 belong to the function and the function is odd, therefore negative 3, 81 also belong to the function. Therefore, the value corresponding to negative 3 is 31. The right choice is A. Which is question number 8, which is differentiable at x equal negative 2. Let us check the continuity and the differentiability of these four functions. F of negative 2 for the first function, 1 minus 4 times negative 2, 1 plus 8, minus 4, let us do it here, 1 minus 4 times negative 2 minus negative 2 square equal to 1 plus 8 minus 4 equal 1 to 5. 1 plus 8, 9 minus 4, 5. For the continuity, we need to find the limit from left and from right. From right, it is 5. From left, substitute in the first segment, negative 2 square plus 4 times negative 2 plus 2 equal to negative 2 square, 4 minus 8 plus 2, 4 minus 8, negative 4 plus 2, negative 2. Since 5 not equal to negative 2, then this function is not continuous, therefore it is not differentiable. For the second function, f of negative 2 is 0, and the limit from the negative 2 from right also is 0. From left, is negative 2 minus 0 limit when x approach to negative 2 from left. Substitute in negative 2 minus x also is uh, 0. Negative 2 minus 2 is 0. Therefore, this function is continuous. Let us check its differentiability. If we find the derivative of both segment, negative 2 minus x minus 1, x plus 2, 1, when x less than negative 2, when x greater than or equal, sorry, when x greater than negative 2. If we want to find the limit of the derivative from left and right, we will find that from left is negative 1 and from right is 1. Therefore, this function is continuous, but it is not differentiable. For the third function, negative 2, for the third function, negative 2 is not in the domain of this function. Therefore, this choice is wrong. Let us check the fourth function. It should be the right choice. Let us check the continuity. F of negative 2, 4 times negative 2, negative 8 plus 7, negative 1. If we substitute in the first segment 4 minus negative 2 square, 3 minus negative 2 square, 3 minus 4 equal negative 1. Therefore, this function is continuous. For the differentiability, f of prime of x equal to negative 2x when x less than negative 2, 4 when x greater than negative 2. The limit of the derivative of this function is 4 from the right and from left. Limit x approach to negative 2 from left, substitute in this segment, negative 2 times x equal to negative 2 times negative 2, also 4. Then this function is continuous and differentiable at negative 2. See you next lesson.